Welcome to Function Rules. Today's essential question: how are symbols such as less than, greater than, and equal to useful? Our vocabulary today has several terms that you need to make sure you write down. Go ahead, pause the video if you need to make sure you got everything. A sequence is a list of numbers in a specific order. Each number in the list is called a term of the sequence. Arithmetic sequences can be found by adding the same number to the previous term. In a geometric sequence, each term is found by multiplying the previous term by the same number. Today we're going to be looking at geometric and arithmetic sequences and finding the next few terms based on what we're working with. In our first example, we're going to describe the relationship between the two terms in the arithmetic sequence of 7, 14, 21, and 28. And then we're going to find the next three terms. Our first question we can ask ourselves is, what do we need to do to the first term to get to the second? So from here to here, what are we doing? Well, we can either add 7 or multiply by 2. So then let's take a look at our next set of numbers there, 14 to 21. How can we get to that next number? We have to add 7. And if you go back to our definition of an arithmetic sequence, they are the same number. There's no difference in them. It's the same number either multiplied or added. So in this case, we have to do the same thing from term to term in order for us to have a correct sequence. Since we can't multiply 14 times 2 to get 21, we're going to go ahead and add 7 in between each of these jumps. So since each term is found by adding 7 to the previous term, we can go ahead and continue the pattern to find the next three terms. So if we add 7 to 28, we will get 35. If we add 7 to 35, we will get 42. And if we add 42 and 7, we will get 49. So the next three terms in the sequence are 35, 42, and 49. And our relationship is we are adding 7 to the previous term. Let's take a look at another example. Describe the relationship between the terms in the geometric sequence 2, 4, 8, 16. Then find the next three numbers. Very similar to what we did previously. But if you take a look at some of the wording in this term here, we're looking at a geometric sequence. And according to what we know about the definition of a geometric sequence, it's found by multiplying the previous term by the same number. So all we need to do is figure out what number that is so we can multiply. If we take a look between 4 and 2, what number would we multiply to get there? Times 2. If we're looking at 4 and 8, it's also times 2. And from 8 to 16, which is also times 2. Since we're multiplying by 2 each time, we can go ahead and find the next 3 terms. We can multiply 16 times 2 to get 32. We can also multiply 32 times 2 to get 64. And we can multiply 64 times 2 to get 128. So the 3 terms that we're looking at in this sequence are 32, 64, and 128 are our next 3 terms. A sequence can be also shown in a table. The table gives both the position of each term in the list and the value of the term. So if you look on the left here, we have our list of 8, 16, 24, and 32. And at the right, we have a table where it tells you the position of the number within the sequence and what the value of each term is. You want to write an algebraic expression to describe the sequence. And how we're going to do that is we are going to be looking at the position. The position row there, it can be considered the input, and the value of the term is the output. So we're trying to figure out a way to describe it in words and symbols. So if you're looking at the position number 1, there's only really one way there's 2 ways you can get it. It could be a plus 8 or a times 8. So if you're looking strictly at this row here, it's either going to be a plus 8 or a times 8. So a plus 8 or a times 8, just keep that in the back of your mind. If you're looking at the second row, where it's position number 2, right here, how do you get from 2 to 16? Well, you can multiply by 8. Okay. Third row, from 3 to 24, multiply by 8, and the fourth row, multiply by 8. So if we were going to continue this sequence, and we wanted to figure out, let's see, what the 6th term would be, what we would do is we would make n the number of the sequence, and then we can decide what we're multiplying by, because we said we multiplied by 8 through each of these. So our algebraic expression would be 8n for the sequence. If I wanted to find the 6th term, I would take 8 times n, which represents the position of the number. So it would be 8 times 6, which would give me 48. This is a way that you can jump ahead and see the terms would be quite a ways down the line. I'm going to leave you with some got it problems. The first 2 deal with describing the relationship in each pattern. So telling me how you got from here to here, and then finding the next 3 terms for A and B. The last one I'm going to leave you with is completing the table. You're going to use words and symbols to describe the value of each term as a function of its position, then find the value of the 8th term. So remember, look at the position number. How do you get from 2 to 12? That's what you're going to be using. So you can describe it in words, write the expression, and then tell me the value of that 8th term. Good luck, and I will see you soon.